So this is the extra example from 21.2, which is solving quadratic equations with context. So Manny is building a rectangular swimming pool in his backyard. The pool itself will be 12 feet wide by 26 feet long. There's a sidewalk of a width X surrounding the pool. So that's the picture that's drawn there. It has a pool that is 12 feet wide. So that's this distance. The length is 20 feet long, or sorry, 26 feet long. That's that distance. And then there's a sidewalk with a width of X surrounding the pool. So that's what's in gray. Can't really see the highlighter over the gray, but that's what it is in gray, is that X width of sidewalk all the way across or around the pool. Okay, so now if the pool and the sidewalk together take up 576 square feet in Manny's backyard, what is the width of the sidewalk? So including basically this whole rectangle, the pool and the sidewalk surrounding it. So this whole length and this whole length, that takes up 576 square feet. So that's how much area it's taking up, and this is a rectangle. So in order to set up our equation, we need to know the formula for the area of a rectangle. Area of a rectangle is length times width is equal to area. So we know the area is 576, so that's what we get to put in for A. For length and width, it can be really tempting to put in like 12 for 12 for W for the width and 26 for the length, but those don't include the sidewalk, unfortunately. So we have to do a little bit more, work to get those. So if the original length of the pool, or if the length of the pool in general is 26 feet, but there's an additional X on each side because the width of the entire sidewalk is X, then we can write the length as 26 plus X plus X. But then we can just go ahead and combine the X's. So if I have an X and another X, I have two X's, so it'd be 26 plus 2X. And then trust me on this, if we write the 2X in front of the 26, it makes us do like one less step later on, so that's what we're going to do. So 2X plus 26. That is the length of the pool with the sidewalk. And then we have to do the same thing for the for the width of the pool, because the width is 12 feet, but then there's an X on the top and on the bottom. So it would be 12 for the width plus X, oops, forgot the plus sign, plus X. And then, of course, we can add the two X's together. If I have one X plus another X, that's 2X. And then I'm going to do the same thing here. I'm going to write the 2X in front of the 12. It just gives us like one less thing to do when we have to FOIL, which we haven't really gotten that part of the problem yet, but you'll see. Just trust me. Okay, so this is our width, including the sidewalk. It's the 12 width from the pool plus an X on each side. And then this is our length, including the sidewalk. It's the 26 length from the pool and two X's, one on each side. Okay, so we will take the length, 2X plus 26, and we'll put that in for L. And we'll take the width, 2X plus 12, and put that in for W. Because there are multiple terms, like the 2X and the 12, those are two separate terms, we have to put both in parentheses. So for the length, it'd be 2X plus 26. And then for the width, it's 2X plus 12. And then is equal to the area, which is 576. So kind of when you look at this problem, you might be like, oh, cool, it's like already in factored form. Which it is kind of, but in order to solve things in factored form, we have to have a 0 on the other side of the equal sign. And we can't just like get rid of that 576. So in order to like truly get it in the correct form to be able to solve and factor, we'll have to FOIL this side and then subtract over the 576. So it's gonna be a little bit more work. Okay, so FOIL is, remember how we multiply two binomials together? So the F in FOIL stands for first. I'm gonna actually just talk about it in terms of distributing, I think, instead of the acronym. So first we take the 2x and we'll multiply it by both of these. So I'll do 2x times 2x. That is 4x squared. And then 2x times 12 would be 24x. So I've distributed the 2x, so I'm done with that part. And then next I'll distribute the 26x. So 26x times 2x would be 52x. And then 26 times 12 is, I have no idea, so get a calculator. 26 times 12 is 312. So it'd be plus 312 at the end equals 576. Okay, and then now we want to check for like terms. So those are terms of the same variable with the same exponent, which are those 24x and the 52x. So I'll bring down the 4x squared, and then 24x plus 52x, you need to add 24 plus 52, which is 76. So this would be plus 76x. And then I'm going to bring down that plus 312. And then I'll bring down my equal sign and my 576. So the ultimate goal is to get a 0 over here. So next I just need to get rid of that 576. In order to do that, I'll have to subtract it. So minus 576, and then I'll subtract the 576. And I can subtract it directly from the 312 because those are like terms since they both don't have a variable. So I would bring down my 4x squared and then my plus 76x. And then now I can subtract 312 minus 576. So 312 minus 576 is negative 264. And then is equal to 576 minus 576 is 0, which is exactly what we're trying to do. Okay, so now this is in standard form. Remember, standard form is, I'm going to write it over here and then I'll probably end up erasing it, but it's ax squared plus bx plus c is equal to 0. Okay, so ax squared plus bx plus c equals 0. We have 4x squared first, 76x second, minus 264, and then is equal to 0. So we're all good. Now we're ready to start factoring. So remember, the first thing you're always supposed to check for when you're factoring is GCF. So these are pretty big numbers. So like sometimes when we find GCF, we list the factors, like listing the factors of 76 and listing the factors of 264. Sounds less than ideal to me. So another kind of trick that we can use is like this number 4 is relatively small. So I can just check to see if 4 happens to be a factor of 76 and of 264. If it is, that'll be my GCF. Okay, so I can do 76 divided by 4, and you can use a calculator to check. 76 divided by 4 is 19. So that works, that's a whole number. And then 264 divided by 4 is 66. So that's a whole number also. So one thing we can do is we can factor 4 out as the GCF. I want to show you the other way though, or what you can do in this case. So since our GCF was 4 and we have an equation, meaning there's an equal sign, we don't have to, we can factor out like normal GCF, but we can just divide everything by 4. You cannot do this if you have an expression, meaning there's no equal sign, and you cannot divide an equation by an x. You can only do it by a regular number, one that doesn't have a variable. So now if we divide everything by 4, 4x squared divided by 4 is x squared. 76x divided by 4 is 19x. And then negative 264 divided by 4 is negative 66. And then that's equal to 0. And then now with that 4 out, we're like really ready to factor. So a, the coefficient of x squared is 1. B, coefficient of x is 19, and then C, the constant is negative 66. So because A is 1, I just need numbers that multiply to C and add up to B. So it'll be, I'm going to erase this part now. It'll be multiply to negative 66 and then add up to positive 19. So I'm going to make a list of the factors of 66. So for 66, I know that like this isn't really on the times table, so we don't have, or I mean it's 6 times 11, but a lot of the factors we won't really think of. But it's always 1 times 66. And then 66 is an even number because it ends in an even number, so that means we can divide it by 2. So you can do 66 divided by 2, which is 33. So 2 times 33. You can check to see if it's divisible by 4, or sorry, by 3. So 66 divided by 3 is 22. So 3 times 22. You can check to see if it's divisible by 4. 66 divided by 4. It's not, you get a decimal, but this is actually enough right now. So since they're multiplying to negative 66, one of the numbers will have to be negative. So we just have to pick the combination that has a difference of 19 in this case. So 3 and 22. Like if I take 3 and, or if I take 22 and I subtract 3, I get 19. And knowing that they have to multiply to negative 66, I'm going to have to make one of my numbers negative. So if I make the 3 negative, then 22 plus negative 3 or 22 minus 3 would add up to 19. So for my factors, I have a trinomial, so it's going to factor into 2 binomials in their own parentheses, and then equals 0. And then because this is just a 1x squared, that has to break down into x and x. There's no other way. And then these are what fill in the rest of the parentheses. So minus 3, and then plus 22. And then now I can set each factor equal to 0 to finish solving. Okay, so one factor is x minus 3. I'm going to write them over here. So x minus 3 is equal to 0. And then the second factor is x plus 22. So x plus 22 is equal to 0. And now we can solve both separately. So I'll start with the x minus 3. To cancel out the 3 that's being subtracted, I have to add 3. So I would add 3 to both sides. I'll bring down my x. Negative 3 plus 3 is 0. That cancels out. And then that's equal to 0 plus 3, which is 3. And then for the second equation, x plus 22, if I want to cancel out the 22 that's being added, I have to subtract it. And then I bring down the x. 22 minus 22 is 0. That cancels out. And then bring down the equal sign. 0 minus 22 is negative 22. Okay, so we ended up with 2 answers again. That's typical for like a quadratic when you have x squared. But because we have context in this problem, that context can help us decide which one is the actual kind of correct answer for this problem. So if we go back to this like second line right here, it says, what is the width of the sidewalk? And the width of the sidewalk was represented by x. So since we got x equals 3 and x equals negative 22, those are the possible combination, or the possible like widths of the sidewalk. And it's in feet because we were given the area in square feet. So between x equals positive 3 and x equals negative 22, which one can the width be? Because you can't have a negative width. We can't say the sidewalk is negative 22 feet wide. You can never have a negative like width or length. So that means that our solution for this problem would be x equals 3. So we can say the sidewalk is 3 feet wide.